Hi to you watching this video. So for this video, we're going to discuss about steel works. Okay. So steel reinforcement, it is most widely used reinforcing material for almost all types of concrete construction. Why? Because it is an excellent partner of concrete in resisting both tension and compression stresses. Okay? If it is a deformed bars like this, ito yung deformed bars, ito yung kadalasan natin nakikita. Okay? On a construction project. Now, if it is a deformed bars, it is only good in resisting tension forces or tensile forces. Why? Because if it is going to resist compressive forces, imagine the diameter, for example, 10 mm, d 10 mm, and it is 6 meters. You're going to apply a compressive force, magkakaroon ng buckling yung uh, ating steel. So it is very weak in compression. Okay? But if it is a form bars, like for example, it is a I-beam, wide flange, or channel section, it is very good in resisting compressive forces as well. Okay, so it depends on the cross-sectional area of the steel. Now, comparatively, steel is 10 times stronger than concrete in resisting compression load. Okay, and 100 times stronger in tensile stresses. So I repeat, it depends on the cross-sectional area and the length of the section. Okay, so what are the standard weight of plain or deformed round steel bars? So why do we need to have the weight? Because for example, in contracts or in bidding, ang ginagamit natin or in computing our bill of quantity, ang ginagamit natin dyan is in kilos. Yung steel bars natin, deformed steel bars or deformed bars would be in kilograms. Okay? But when we buy them in our supplier, it can be bought in per piece. So let's say 200 pieces of D10 mm by 6 meters yan. So pieces ang pinag-usapan. Pwedeng pieces, pwedeng in terms of kilogram. But if it is a big project, more often uh, pwede mo siyang orderin in its weight. Okay? In its weight form. Though pwede rin naman sa mga supplier na orderin mo siya in pieces. Okay? Now, what are the diameter sizes? So you have here the diameter sizes and the length, and that will give you the weight per kilogram. Okay? So an 8 millimeter diameter of 5 meter length na RSB is 1.98 kilograms, while a 30 millimeter diameter of 6 meters RSB is 33.29 kilograms. Okay, so mamaya magagamit natin itong table na to in order for us to convert our computed numbers of deformed bars into its weight. Okay, so identification of steel bars. So N stands for number of belay, A is for axle, rail sign is for rail steel. Okay? So you have here your main ribs. Ito yung main parts ng ating RSB. This is your main rib, this is your main rib, main rib, main rib. Now, etong M dito, it is the initial of the manufacturer. And nakalagay din dyan sa second or yung number na nandyan, single digit, or actually hindi lang siya single digit, pwede it can be double digit din because like what we have said, we have different sizes of RSB. So the number here indicates the bar size. Okay, then yung next letter, that would define the steel type, okay, or the grade. So it's either grade 33, grade 40, grade 50, grade 60, grade 75. Okay? Now, the best way to confirm yung grade nung ating material is for tensile is to do the tensile testing. Okay? So, ilalagay natin siya sa UTM. Then from there, we can determine the tensile strength of the RSB. Okay? Yan. So additional consideration in estimating the quantity of reinforcing steel bars is the bar spliced, hook, and bend. Okay, I repeat, the splicing, the hook, and the bend of your RSB. So ano ba yung tinutukoy nating splice? Mamaya explain natin yan. Okay? Now, the commonly available commercial length, kaya nga sabi natin commercial because it is common. Okay? So, the commercial length of your RSB is 6 meters, 7.5, 9, 10.5, and 12 meters. Okay? So, if you are going to design structures, it is best that you first determine the commercial sizes para readily available yung material natin. Now, if it is a special project, then we can go directly to the manufacturer, or if hindi wala tayong kakilalang manufacturer, we can say it to the supplier, then the supplier can have a special order for that. Okay? Now, the reinforcing steel bars diameter, we have the, though hindi lang ito may iba pa. We have the 10, 12, diameter 16 mm, diameter 20 mm, D25 mm, D32 mm, D36 mm, and D50 mm. But for D36 and above, so most of the time these are special orders. Okay? Yan. Special orders na tong mga to and above. Okay? So with everything said, we are now ready to estimate our uh, steel works. Okay, so starting off with the footing. So in this picture, you have here the footing steel reinforcement. So this is the reinforcement for the footing pad. Okay, yan. So for the footing pad, it can be a case of a combination of top and bottom bars, or it can only be a bottom bars. Okay? So, pwedeng bottom bars lang kasi yung footing pad, or pwedeng combination siya ng top at saka bottom bars. Okay? So, what are the consideration on the footing pad? First would be the spacing. The spacing of your reinforcing steel bar this way and that way. But if it is an isolated footing, pag isolated footing yan, kadalasan kung ano yung distance ng spacing dito, yun din yung distance ng spacing dito. But if it is isolated square footing rather, what I'm pointing out here is the isolated square footing. Meron din kasing rectangular, okay, and trapezoidal. So if that would be the case, if combined footing na siya or hindi na siya isolated square footing, more or less mag-iba yung spacing natin. Okay? But just refer it from the schedule of footing. Okay? So we have here our example number 1. Okay, so the first thing that we need to estimate is the footing. Okay, so let's go to our S. Okay, so S, schedule for footing. Now the schedule for footing is on page S3. S2. Okay? So dito sa S2, if we're going to take a closer look, pare-parehas. Okay? So 1 meter by 1 meter, 1 meter by 1 meter, and 1 meter by 1 meter also. So ibig sabihin, lahat nung footing natin is 1 by 1 meter. Now if we're going to check our footing schedule, let's try to check. Our footing schedule is 8, 16, D16, 8 pieces, both ways. So, 1, 2, 3, 4, 5, 6, 7, 8. So, ibig sabihin, yung spacing, yung pieces natin on this way is 8 pieces. And ang sabi niya, both way. So, ibig sabihin, parehas na pag ganito at pag ganito, the spacing is, or the reinforcement are to be 8 pieces. Is to be 8 pieces. Okay? Yun yung ibig sabihin ng both ways. Okay? Now, let's check for F2. Now, for F2, we have here Wait, let me zoom. Let me clear. Focus that. Ayan. So, sabi dito, 8 pieces of 16 mm diameter horizontal bars equally both ways. Okay? Ibig sabihin, we have here 8 pieces yung paganito, 8 pieces din yung paganito. So, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, checking for F3, according to the schedule, it is no, that's for the column. Ito, checking for both ways, we have here 8 pieces of D16 mm diameter. So, 8 pieces, and it is again both ways. So, 8 pieces na pa ganito, then 8 pieces na pa ganito. Okay? So, since they are the same, what we're going to do is to count. How many footings do we have? So, going back to S1, so this is my S1. How many footings do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So all in all, I have 15 footing pad. Okay, so going back here, yan. Ito lang, pareha siya. We have here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there are, all in all, there are 16. Okay? Now, what would be the length ng isang bar? Okay? Or what would be the length of the reinforcing steel bar? Ang nire-refer natin na length ng steel bar is ito. Okay? Yung isang piraso lang muna. So, the length of one steel bar is equivalent to 1 meter. So, that is 1 meter. Minus, meron tayong tinatawag dito na concrete cover. Okay? So, if you have not tackled this yet in your RC, we have here the concrete cover. And for a footing, the minimum concrete cover is equivalent to 75 mm. Both sides. Okay? Tig 75 yan. Now, for the length of the RSB, so that is 1 meter minus the concrete cover. So, let's convert that into meters. And that is 0.075. But it is on both sides, so times 2. Okay? Next is, if you're going to look at the cross-section of the footing, okay, kung titignan natin maigi, yung cross-section ng footing natin, yan. Meron tayong tinatawag dito na hook. Okay? So, we have here the hook. So, for the hook, we're going to use 0.1 meter. But again, it is on both ends. So, may hook tayo dito, may hook tayo dito. So, that would be plus 0.1 and times 2 kasi both ends. Okay? Therefore, the length of the RSB is equivalent to 1 minus 0.075 times 2 minus 0.1 times 2. Wait. No, it's not minus. It should be plus. Therefore, it is 1.05. So, 1.05 meter. So, 1.05 meter is the length of the RSB. Okay? So, yan na yon. So, again, like what we have said a while ago, we have different commercial length. We have the commercial length of 6 meters, 7.5 meters, 9 meters, 10.5 meters, and 12 meters. So, it depends kung anong commercial size yung available. Okay? And kadalasan, ang ginagamit natin is 6 meters. 6 meters yung ginagamit natin. Now, in this problem, what I'm going to use is the 6 meter commercial length. Now, I need to get the factor. Ano yung factor? Ibig sabihin, ilang 1.05 meter ang makakat ko sa isang 6 meters. Okay? So, 6 meter commercial length divided by 1.05. So, ilang 1.05 ang makakat ko sa isang 6 meter. And that is equivalent to 6 divided by 1.05. And that is 5.71. So 5.714 meter. But here, what I am going to adopt would only be the whole number. Kasi wala tayong wala nang kumbaga excess. Si 0.714 would be excess. Kasi hindi natin pwedeng pagdugtungin yan. Okay? In the footing, hindi natin siya pwedeng ipagdugtong. Okay? So, that would be equivalent to 5 pieces. So, I am going, no. It should be here. 5.714 cuts. And that is equivalent to 5 cut per 1 piece of 6 meter length. Okay? Now, how many cut bars do I need? So, ano ba yung cut bars natin? Ito yung cut bar natin. So, we have 1, 2, 3, 4, 5, 6, 7, 8. So, 8 cut bars times both ways siya. So, times 2. Or pwede nyo nang idiretso dito yung 16. Okay? So, 8 times 2 times the number of footing. How many footing do we have? We have 15. Okay? So, we need 8 times 2 times 15. That is equivalent to 240 cut bars. Okay? So, how many, ngayon, alam na natin, now we know that I need 240 cut bars of this size. Okay? Now, how many 6 meter length RSB ang bibilhin natin or ang gagamitin natin? Now, I'll be dividing the 240 divided by the factor. Kasi sa isang 6 meter length, 5 lang ang magagamit natin. So, that would be 240 cut bar. 240 cut bars divided by 5 cuts per 1 6 meter length. Okay? So, cuts will cancel out and yung RSB mapupunta sa numerator. Therefore, 240 divided by 5 is equivalent to 48. Okay? So, maliit ito kanina. So, I'll be needing 48 pieces of the 16 mm by 6 meters. So, this would be the final answer for the reinforcement for the footing pad. Okay? Next step would be the tire wires. Okay? So, yung tire wires, ang ginagamit natin dito is number 16 GI tire wire. Okay? Or mas kilala natin to as alambre. Of course, this reinforcing steel bar will not be hooked by itself. So, kailangan natin itali yan sa intersection. Okay? So, we need to tie that on the intersection. Okay? So, itatali natin yan. Now, for the length of the tire wire, it depends on the practice of the steelman. Kasi minsan ang ginagamit nila, it's ranging from 0.2 meter to 0.4 meter yung haba ng alambre. So, this is 0.2. Tapos, this is 0.3. Tapos, ifo-fold nila yan into two sides. So, nakaganyan yung alambre. Okay? Naka-fold yan. Then, yun na yung gagamitin pang tali. Okay? So, itatali sa intersection. So, in our case, we're going to use 0.3 meters. So, we will use the average. Now, 1 kilogram of tire wire is equivalent to 53 meters. Now, to get the kilogram of the tire wire, we need first to get the number of intersection. So, how many intersection do we have? Isn't it that this is 8 by 8? So, it is simply 8 times 8. So, 8 times 8. So, that is around 64 intersections. Okay? Then, number of footing. How many footing do we have? This is not 10, but this is 15. Okay? So, 15. So, ilang footing yung meron tayo? We have 15 times. Ano yung length na gagamitin natin? That is 0.3. Therefore, yung total na haba na gagamitin natin na length of tire wire for all of the footing is equivalent to 8 times 8, 64, times number of footing, 15, times the length of the tire wire, which is 0.3. Therefore, that is 288 meters. Okay? Now take note, for every kilogram of tire wire, it is equivalent to 53 meters. Now, to get the kilogram of tire wire, 288 meters times per kilogram of tire wire, we have 53 meters. So meter will simply cancel out. We will be left with kilograms. Okay? So that is 288 divided by 53. And that is equivalent to 5.434 kilograms. Now here, we're not yet going to round it up. Okay? Hindi muna tayo mag-round up because we will still be using tire wires for the other parts of the steel reinforcement. But here we can round it up already because because of the cut, we can no longer use that for other parts. Okay, other parts of the reinforcement, unless if it is for, let's say, if we can use that for the point, where is that, the 0.714 meter. If we can use that for the tire wires, for the lateral ties, or for the stirrups, then we can do so. But take note, the diameter here is 16 mm. Iba yung diameter na gagamitin natin sa ties. Okay? But if it is the same, then we can use that. Okay? Or if we can use the excess in some parts, then we can do so. Okay? But here, we can round it up already to whole pieces. Okay? Next step would be the column. Okay, so for the column, mag-start tayo from the footing going up to kung hanggang saan aabot yung natin, bakal natin. Kasi dito, idudugtong naman natin yan. Okay? So, idudugtong natin yan. Now, for the column, let's go for footing side. Wait. But before that, ano ba yung mga kailangan natin i-consider for vertical reinforcement and for the column? Now, for the length of the reinforcement, we need to have the bend. Ano ba yung bend na yan? This bend is, you can compute this from your reinforced concrete. This is being given by the we have the provisions here from the NSCP, which is 16 bar diameter. Okay? So, yung bar diameter natin, ano ba yung bar diameter natin for the column? Mamaya, check natin sa schedule. Or, nandito naman siya actually. The main vertical, it is diameter 16. Okay? And for the ties, nandyan naman, it is 10 mm diameter. So, hindi natin pwedeng gamitin yung excess sa footing sa lateral ties. Now, for the vertical reinforcement for the bend, we have here 16 times the diameter bar. So, 16 times the bar diameter, which is, again, 16. Okay? So, 16 times 16, that is 256 mm. Okay? But, again, I will not encroach with that. Ang gagamitin natin for I will not encroach with your reinforced concrete. And don't worry, ang gagamitin nating value is safe. So, we are going to use 300 mm in our estimation. Okay? 300 mm for the bend. So, ano ba yung bend natin? Yung bend natin is this one. Okay? Ito yon. So, this is the bend. So, ang gagamitin natin dito sa bend natin is 0.3 meters. Okay? Now, from the footing to the footing pad, wait, let me show you. Okay, so ito, for example, this is your footing, okay, and this is your reinforcing steel bar, vertical reinforcing steel bar. Ito yung ito yung bend. So, the bend is equivalent to 0.3 meters. Now, the height of the starting for the footing would be 1/4 of the height of footing pad. Now, for example, let's say this is from the footing pad. Meron tayo dito na 0.3. The height is 0.3. Therefore, this one here is 1/4 of 0.3 meters. Okay, and that is equivalent to 0.075. Okay? So, yan. But if let's say sabihin natin na yan yung it is not 0.3, sabihin natin it is 0.4. Then definitely that is 0.1. Okay? So doon tayo mag-start. Kasi take note, nakapatong din naman yan. Nakapatong yan sa ating reinforcing steel bars. Okay? So sa footing pad. Okay? Now, by the way, for our case here, based sa ating footing plan, if we are to check it here, bottom bars lang meron tayo. Okay? So bottom bars lang yung meron tayo. If it is a bottom and top bars, if it is a bottom and top bars, we are just going to multiply it by 2. Ito, i-multiply lang natin siya sa 2. Kasi more or less, the spacing on the bottom bars is the same with the spacing on the top bars. Unless it is again specified by the schedule. Okay? So, balikan natin yon. Okay, so nandito na tayo. As a bend, we will be using 0.3. Now, after that, we have the bend up to the upper face of the footing. So, ito yon. From the bend to the upper face of the footing, which is 3/4 of the thickness of the footing. So, this is 1/4. Therefore, this height here is equivalent to 3/4 of height of the footing. Okay? Then, from the footing to the natural grade line, so this is the footing to the natural grade line or the ground floor line. Then, diretso siya papunta dito. This would be the height of the column plus the beam, then the slab. Okay, beam, slab, then for the dowel bars. When we say dowel bars, ito yung mga nakaabang. So, nakaabang yan kasi dyan idudugtong yung next part or yung continuation ng ating reinforcing steel bars. So, for the dowel bar, we are going to use 0.4 meter. So, this is your dowel bar. We're going to use 0.4 meters. Okay? Okay, so we can now go back to our estimation. Now, here, we have here 0.3. Yeah. For the bend, we have here 0.3 meters. Now, from the bend to the upper face of the footing, that is from the bend to the upper face of the footing, so that is 3/4 times the height of the footing pad, and that is 0.3 meters. And that is equivalent to 3/4 of 0.3. That is 0.225 meters. Now, from the footing to the natural grade line, that is 0.9. 0.9 meters. Now, take note. Babalikan natin yung ating footing schedule. Take note that is just only applicable for F3. It is only applicable for F3. Okay? Kasi yung F2 and F1, from the footing to the natural grade line, that is 0.8 meters. So, ilan yung F3 natin? So, let's check. We have 1, 2, 3, 4. So, this one here is for F3 only. For F3. Now, for the F1 and F2, I'll give it to you as your exercise. Okay? Again. So, ang isosolve lang natin dito would be for the F3. So that is 0.9 meter. Now from the finished grade line to the second floor, we are going to base that from our elevation. So, balik tayo sa architectural. So, ito. Take note, ang inestimate natin kanina, sabi dito, from natural grade line. Magkaiba yung natural grade line at saka yung finished grade line. Okay? So, yung natural grade line, ito, yung finish kasi, finish floor grade, ito yung finish floor grade natin. Take note, dito tayo nag-stop. Okay? We stopped from here. So, hindi tayo pwede magtuloy dito kasi kasama pa rin ito. Now, from this point up to here, floor ceiling line. So, that would be negative 0.2. So, let's say that is, yeah. So, natural grade line natin, wait. Okay, so yung ating parking floor line, is mas mababa siya compared sa ating natural grade line because that is negative 20. Okay? So, so negative 20. So, yan. So, we have here at elevation 200, ay elevation 0. So, I think we can start naman na sa 0 because the natural grade line, supposedly is your 0 elevation. Okay? So, the natural grade line supposedly is your 0 elevation. Now, with that, since our floor line is at elevation 0, let's use this as our starting point for the height of the column. Now, for the height of the column, it is up to the first floor ceiling line. So for the first floor ceiling line, we have here the 2.9. Okay? Kita ba? Ayun. So we have here 2.9. So from elevation 0 up to the first floor ceiling line, that is 2.9 meters. So, gamitin natin dito na from the finished grade line to the second floor line. So, that is 2.9 meters. Next, what would be the depth of the beam? Now, again, if we are going to base it here, we have here the second floor line. So, there is a difference of 0.3 meters. Okay? So, we have here the difference of 0.3. Pwede nating, yeah. So, let's say na yan nandyan yung ating beam. So, 0.3. So, the depth and from the schedule, let's affirm or confirm. From the beam, the depth is 0.4, which is, from the second floor, tignan natin yung second floor. Second floor, we have SB, PB. Check natin si SB, PB. We have here SB, at saka si PB. It is 0.4. Okay? Though kasi, pag sinabi natin yung ceiling, nasa baba siya ng beam, di ba? When we say, unless it is a drop ceiling, but in our case, I don't think that is a drop ceiling. Okay? Kasi, second floor line, it is on top of the slab. So, if this is our second floor line, nandito, ito yung slab, andito yung beam. Okay? So, yan. Nandyan yung beam. So, if ito rin naman yung ceiling natin, if this is the ceiling, definitely, nandito yung beam natin. Okay? So, ang gagawin natin is i-check natin yung thickness ng slab. So, ano ba yung thickness ng slab natin? The thickness of the slab. I think it is not given or it is not stated, but wait, let me check. Okay, so hindi nga siya indicated. So in our case, let's use the slab thickness as 0.120 meters. Now for the depth of the beam, it is 0.4 meters. Now, hindi pa tayo tapos dito sa 2.9. Okay? Because, take note, for the second floor finish line, ito yung elevation kung saan nandyan na yung tiles. Okay? Yung tiles, normally, the thickness of tiles is 4 mm. Then, for the mortar, that's around 1 inch. So, I think we can neglect that one. Okay? So, let's say for the second floor line, ibawas natin yung depth ng slab at saka ng beam. Okay? So, take note, the orientation as per schedule, ang orientation natin as per schedule is, na-check na natin to before, would be this, no? Ito yung itsura. So, that would be 120, then we have 0.4. Okay? So, the thickness is 120 and the depth of the beam is 0.4 as per schedule. Okay? So, that is PB and SB. So, 0.4 and 120 mm. So, ibig sabihin, this 0.9 here, this 0.9 this 3.2, idiretso na natin yung 3.2 minus 3.3 rather minus 0.4. Okay, pwede naman natin pag-isahin yung pag-isahin natin kasi ang mag-govern na depth would be the depth of the beam. So the governing depth of the beam is the depth would be the depth of the beam. So 3.2 minus 0.4. Okay? So 3.2 minus 0.4. That is 2.8. So babawasan natin itong 2.9, gagawin natin 2.8. Okay? Or we have here 3.2 minus 0.4. Okay? Yan. Now, for the dowel bar, ang gagamitin natin is 0.4 meter. Therefore, the total length of all of this is equivalent to 0.3 plus 0.225 plus 0.9 plus 2.8 plus 0.4 plus si slab thickness, hindi na natin siya i-add because based on the orientation from our schedule, sa schedule natin, okay, integrated yung height or yung thickness ni slab sa height or sa depth ng beam. Okay, so hindi na natin i-add si slab thickness. But if it so happen na si slab ay nakapatong sa beam, I repeat, if it so happen na si slab ay nakapatong sa beam, then i-add natin si slab thickness. But in this case, hindi na. So, 2.8 plus 0.4 plus 0.4. Therefore, that is 5.05 meters. So, 5.025 meters. Therefore, from here, ang gagamitin nating length is, or the commercial length that we're going to use would be 6 meters. Okay? What if the total length, itong total length na to lumagpas ng 6 meters? Okay? Pag itong total length na to lumagpas ng 6 meters, then gagamitin natin would be the 7.5. Okay? Take note, hindi ka pwedeng kapusin. Wait. Where's that part? Okay, so sabihin natin dito, hindi ka pwedeng kapusin ng bakal dito sa intersection between the column and the uh, the uh, the beam, okay? Because that is a crucial point. Hindi ka pwedeng kapusin. Dapat lumagpas ka sa slab, okay? So if that would be the case, hindi ka pwedeng kapusin. If that would be the case, kunyari, ang lumabas dito is 6.5. So if it is 6.5, then ang commercial length na gagamitin natin is 7.5 meters. But in this case, it is 5.025. Then we use the 6 meter commercial length for the RSB for main reinforcement. Okay. Now, for the main reinforcing bar, how many main reinforcing bar do we need to use for the column? So, ito yung column 1 natin. Check natin sa ating schedule. So, all of them are column 1. Okay? So, this is our column 1. Ilan ba yung main reinforcing steel bar natin? We have 1, 2, 3, 4, 5, 6. So, we have 6 pieces per column. Okay? So, 6 na piraso na main reinforcement, vertical main reinforcement for the column. Okay? So, we have here 4 D16mm corner bars. So, these are your corner bars. Then, 2 D16mm. So, dalawang intermediate bar. So, these are your bars. Okay. So, 6 pieces per column. So, how many columns do we have? Take note, this is just for F3. Okay. So, F3 lang ang pinag-uusapan natin dito. Now, for F3, base it from the plan. Basing it from the plan, we have apat, if my memory serves me right. So we have F3, it's S1. So we have here 1, 2, 3, 4. Yes, so we have 3 CF3. Okay, C1F3. So we have here 4 columns. Okay, so 4 times 6, that is 24. So we have 24 pieces of D16mm by 6 meters. So ito, we can already use the 24 kasi like what we have said a while ago, mag-extend naman yan sa pataas. Then dun tayo splicing. Okay? Okay, but what if, okay, so what if ang ginamit natin is for all the column na. Take note, dito kasi why we considered F3, here because from the footing to the natural grade line, yan, from the footing to the natural grade line for F3, it is 0.9. Okay? But what if we're going to use 0.8? Actually, pwede. Kasi ang mag-iiba lang naman dito, instead of 0.9, it would become 0.8. So, if 0.8, yan, ano yung magiging total length natin? So, this is 5.025. Actually, pinalitan ko kasi itong solution paper because nalubat yung aking pang record. So, hindi na record yung iba kong sinasabi. But anyways, yeah. So, what if it is 0.8 rather. Okay, so let's calculate that one. We have 0.3 plus 3/4 of nandun na pala, 0.225 plus 0.8 plus 2.8 plus 0.4 plus 0.4, and that is equivalent to 4.925 meter. Okay, so if it is 4.925, it is still the same. We are going to use the 6 meter commercial length. Okay, so 6 pieces. So if we're going to count everything, no, so 6 meters, 6 meter length, then 6 pieces per column, instead of 4, we're going to use 15. Now, 6 times 15, we have 90. So, we will be using 90 pieces of D16 mm by 6 meters. Okay? So, next would be the lateral ties. Now, what is the function of a lateral tie? So, a lateral tie, it is the one that holds the main reinforcing steel bar so that hindi magkakaroon ng buckling. Okay? Lalo na pag binubuhusan na natin yan ng semento. And at the same time, it resists shear force and thus contributes in avoiding shear failure. Okay? That is the function of a lateral tie. Now, the difference between a lateral tie and a, what do we call the other one? Stirrups. Lateral ties are used for column while stirrups are used for beams. Okay? Okay. So, lateral ties. So, lateral ties, first we need to determine the perimeter or the length of your lateral tie. Okay, so ito yung lateral tie natin. So, the length of the lateral tie is equivalent to the perimeter of column minus 0.1. Okay, so that would be 0.2 times 0.4 times 2. Diba? So, 0.2 times 2 plus 0.4 times 2. 0.2 times 2, 0.4 times 2. And that is equivalent to 1.2 meters minus 0.1, and that is equivalent to 1.1 meters. Okay? Okay, so let's try to derive or let's try to make sense of this formula wherein the lateral ties, the length of the lateral ties is equivalent to the perimeter of the column minus 0.1. Now, for example, this is your column. Okay? Ito yung column natin. These are your main reinforcing steel bars. Then, ito yung ating lateral ties. Okay? Now, take note here, we have what we call the concrete cover. So, the concrete cover, let's say it is the minimum 0.04 meters or it is equivalent to 40 mm. Okay? So, ang gagawin natin para makuha natin yung length is to get the perimeter again, still, perimeter of the beam, which is the width and the depth. Ay, hindi pala to beam, column, which is the two-dimension or the two-face of the beam. So, 0.2 minus 0.4, ito, for the concrete cover, then minus 0.4, and multiply it by 2. Because we have this side, we also have this side. Okay? So, that is times 2. Okay? Next is this side or this face. So, we have 0.4 minus the concrete cover, which is 0.04. This is 0.04, 0.04. Minus another 0.04. Then, we have this side. We have this side and we also have this side. So, times 2. Plus, take note, we have here the hook. Okay? So, yung manggagaling dito, magko-close siya dito. Then, ito, magko-close siya dito. So, we need this hook kasi pag hindi natin yan hinook, pag ganyan, pag sinarado natin yung RSB natin in this sense, okay, so nakaganyan, ito, papasok lang siya dyan. Then, itong bar na to, gaganon lang siya. Pwede pa rin siyang bumuka pag ganon. That's why we have, we used, if my memory serves me right, this is around 45 degrees. Okay? Para umangkla siya dito sa reinforcing steel bar dito. So, that is 0.1, then 0.1. So, 100 mm din siya. So, 0.1 plus 0.1. So, dalawa sila. Okay? So, we have here 0.2 minus 0.04 minus 0.04 times 2 plus 0.4 minus 0.04 minus 0.04 times 2 plus 0.1 plus 0.1. And that is equivalent to 1.08. And that is roughly equivalent to 1.1 meter. So, parehas lang sila ng output. Okay, so 0.1 1.1. 1.1, 1.1. Okay? Okay. Now, for the length of the column, dito naman natin bibilangin kung ilan yung lateral ties. So, what we're going to do is to check, no? From the footing, take note we are still on F3. Babalik tayo sa F3 because we have a different length for F3, F2, and F1. Okay? So, yan. So, yung gagawin nating pagbilang, it would be from the footing pad up to here. Okay? So, take note, we have here, meron tayo ditong grade beam. Okay, so, wait lang. Okay, so going back here, ito yung ating footing. And take note from our structural plan, which is S2. So from S2, we have, yeah, from S2 we have, ay wala pala tayong grade. I think we have a grade beam. Wall footing, second floor. Wait. Wala tayong grade beam. Okay, so wala nga tayong grade beam. If that is the case, dediretso tayo from the footing up to the architectural plan. Where's the architectural plan? Up to here. Okay, so dito tayo. From the footing, imagine niyo from the footing here, aakyat tayo papunta dito. So ito yung i-consider nating length. Okay? Now take note, from the footing up to the natural grade line, it is 9.9 meters. Then from the zero up to sa baba ng second floor line, which is nilagay natin minus 0.4 kasi we have the depth of the beam. So, nangyari, ang magiging height natin dito, clear height natin is 2.8 meters. So, 0.9 plus 2.8 meters. So, ganito kasi ang itsura niya, no? Now, from the footing hanggang dito sa space, sa second floor natin, ito yung ating beam. Okay, so this is the beam. And it has a depth of 0.4 meters. Okay? So, mangyayari niyan, the lateral ties will be starting from dito yan, mag-start na yan from here up to here. Okay? Dito. Kung saan nag-meet sila ni beam sa conjunction. Okay? Sa point of intersection between the beam and the column is what we call the conjunction of beam and column. Okay? So for the lateral ties, we are going to get the distance from this point up to this point. Okay? And that is equivalent to, take note that this is 0.9. The height here is equivalent to 0.9. And here we have the 3/4. Okay? The 3/4 of what do we call that? The 3/4 of the 300, which is 0.225. Okay, 0.225, and this clear height here from the natural grade line up to the bottom of the beam is equivalent to 2.8 meters. Okay. Okay. Now for the spacing, where is that? Yeah. For the lateral ties, we have here the length. Ano ba yung length ng lateral ties natin? It is equivalent to 2.8 meters plus 0.9 plus 0.225 meters. Okay, that is the space where we are going to place our lateral ties. And that is equivalent to 2.8 plus 0.9 plus 0.225. And that is equivalent to 3.2 0.927. Okay? Next, according to our schedule, we have here the 2 at 0.05 meter, 4 at 0.10, and the rest it's 0.15 on center. Okay? Ibig sabihin ng OC, yung yung ibig sabihin we are to measure it from the center. Okay? So 2 at 0.5 meters. So ay, ano ba yung 0.5? 0.05 is 50 mm. Okay? So that is 50 mm. So from here, dalawa ang 50 mm natin. We have as from here, we are going to have a space of 50 mm, then yung lateral ties. Space na 50 mm, lateral ties. So dalawa lang na ganon. Okay? Next would be apat, and it is based on 100. So we have space 100, space 100, space 100. So ilan na yung 1, 2, 3, 4. Next is space 100. Okay? Now, for whatever will be the the spacing here, it will be the same on the other end. Okay? So actually, this is both ends. On center BW, both ends. Yun yung ibig sabihin ng BW. Okay? So, kung dito, that would be space 50, space 50. So, nakadalawa na. Then, magiging space 40, space space 100, space 100 mm. Space 100, space 100, space 100, and space 100. Okay? Then, sabi niya dyan, tapos na yung apat natin number 100, 1, 2, 3, 4. Then, the rest, papuntang gitna. Okay? The rest, papuntang gitna nitong 2.8. So, the center of this is the center is 1.963 from this, from the top going here, or from the bottom going here. Okay, so ibig sabihin yung rest na spacing natin is 0.15. So rest 0.15, rest 0.15, same dito. Okay? Now if we are going to do this manually, matatagalan tayo. Okay? If we are going to do this manually. So what we're going to do is to use the spacing for derive an equation. Okay? And that is equivalent to the number of ties at 15 mm on center spacing. Take note, we know this na kasi. Alam na natin yung bilang nito. So we have 2, 4. Okay, so both ends. So we have 2, 4. So that is 6. Now, what we don't know is how many stirrups or lateral ties will be given by this spacing. Okay, so with that, ang gagawin natin, what is the clear length or the length? It is 2.8 plus 0.9 plus 0.225. That is equivalent to 3.925. Okay, so 3.925. So 3.925 minus 2, which is 0.05, 0.05 times 2 minus 0.1 times 4. Okay? Divided by 0.15. So, ibig sabihin, dito, no. We forgot to divide this by 2. Okay? So, 3.925 divided by 2, where is that? 3.925 divided by 2 is equivalent to 1.963. Okay, so ang ilalagay natin dito is 1.963. Okay, so ibig sabihin, yung kalahati natin, itong kalahati natin, binawas na natin yung spacing ni 0.05 at saka yung spacing ni 0.1. So matitirang spacing na lang natin is 0.15. Okay? So that would be 1.963 minus 0.05 times 2 minus 0.1 times 4 divided by 0.15. And that is equivalent to 9.753. Of course, there is no spacing na 0.753. So we're going to round it up to 10 pieces. A spacing of 10. Okay? So there are 10 spaces. Now, how are we going to get the number of ties for this spacing? So that would be 10 plus 2 plus 4. So 2 plus 4 plus 10. Okay? Then we're going to multiply it by 2 because both ends sila. So dito tsaka dito. So we're going to multiply it by 2. Then plus 1 to get the number of ties. So we have 2 plus 4 plus 10 times 2. That is equivalent to 33 pieces. Okay? But we're not yet done. Why? This is just for one column. Okay? Ilan yung F3 natin? We have 4 F3. So times 4 column, F3 column. So that is equivalent to 33 times 4. So that is equivalent to 132 pieces. Okay? So this is the total number of ties that we need for this specific column, which is F3. Okay? Now, ang na-compute lang natin is number of ties. Now, gaano karaming 10 mm? I think, yeah, it is 10 mm for the lateral ties. Yes. Gaano karaming 10 mm ang gagamitin natin or ang bibilhin natin? Okay? Now, the length is 1.1 meter. So, how many 1.1 meter can be cut from a 6 meter commercial length? Okay? So the commercial length is 6 meter divided by 1.1 meter. So how many is that? I think we have the same answer as while ago. 6 divided by 1.1. So that is 5.45. We only need the whole number. So that is equivalent to 5.455, and we can only adopt the whole number. So that is 5 cuts per RSB. Okay? To get the total number of RSB, we have the number of lateral ties, which is in pieces, times the length of tie per piece, which is equivalent to 1.1 meter, divided by the number of cuts per RSB. Ilan yung number of ties natin? We have 132 pieces. No, it's 130. Is it 132 or 133? Yeah, it's 132 pieces times the length of tie per piece. It is 1.1. Okay, so 1.1. Then cuts per piece. So we have 5. Therefore, the number of RSB that we are going to have is equivalent to 132 times 1.1 divided by 5. So that is equivalent to 29.04. And that is equivalent to 30 pieces. We rounded up, no? Hindi natin pwedeng bawasan yan. So 29.04, that is 30 pieces of the 10 mm by 6 meters. Okay? Next is the tire wires. Now for the tire wires, again, number 16 GI tire wire, we're going to use the 0.3 meter. Now, to get the length of tire wire, we need the number of intersections of lateral ties times the number of lateral ties times the length of the tire wire. Now, how many intersections do we have per lateral tie? So, this is the cross section. We have 1, 2, 3, 4, 5, 6. So, we have 6 intersections here. Okay? Actually, minsan 7 pa yan. Why? Kasi 1, 2, 3, 4, 5. 6 itong isang hook dito, then 7 yung isang hook. Okay? But since it is a 12 mm, minsan pinag-iisa na yan ni pinag-iisa na nung Stillman. But let's use the 7. Okay? So we have here 1, 2, 3, 4, 5, 6 for this hook, 7 for that hook. Okay? So 7. So the number of intersection is equivalent to 7. 7 times the number of lateral ties. How many lateral ties did we have? Ilan yung na-compute natin? We were able to compute 132 pieces times 132 pieces times the length of the GI tie wire, which is 0.3 meters. And that is equivalent to 7 times 132 times 0.3. That is equivalent to 277.2 meters. Now, to get the kilogram, okay, to get the kilogram, we have here 277.2 meters divided by 53 meters per kilogram. So 277.2 divided by 53. So that is equivalent to 5.23 kilogram. Okay, so like what I've said, we're not yet going to round this up because we will still be using GI tire wires for the other parts. Now take note, we're just on the column. Okay, now before we proceed with the beam, I would just to add additional information. Now, meron tayong tinatawag na confinement zone. Okay? Wait. Confinement zone. Dito din. Yung sa nag-stop si 100. 0.5, 0.5, 1, 2, 3, 4. Okay. This is the confinement zone. Okay. So, when we say confinement zone, this is it is a region where we require smaller spacing for the stirrups. Okay? Kaya kung mapapansin nyo, dito at 15 mm on center the rest. Pero dito, we have smaller spacing for the stirrups, which is 0.05 and 0.1 meter. Because this is what we call the confinement zone. What is the reason? The reason is concrete is very brittle and it is weak in tension. Now, during earthquake, nagkakaroon ng build-up. There is a build-up of moment dito sa section na to. Okay? Dito sa section na to. There is a build-up of moment. And to counter the increase in tension, mas nililiitan natin yung spacing sa mas nililiitan natin yung spacing sa dito sa confinement zone natin. Now, what is the value or what is the distance of the confinement zone? It is either 0.45 meters or it is 1/6 of the clear height or the biggest dimension of the column. So whichever here is the lowest will be adopted as the greatest value. Okay? So here we have 0.45, next 1/6 of the clear height. Okay? So actually, dapat, hindi man dapat. Though we expected here kanina na dapat meron tayong grade beam or tie beam. But we have here the wall footing that will also add, no? So if we have here the wall footing, though hindi natin na-check sa plan, if saan nakalocate yung wall footing and if dumikit siya sa column natin, then we are going to consider that the clear height. Okay? So here we have clear height of 3.9. What did we compute a while ago? We have 3.925. 3.925 divided by 6. So that is 0.654, or the biggest dimension is equivalent to 0.4. The biggest dimension of the column. Isn't it that the column is the column we have here 0.4 by 0.2. Okay, so we will be using 0.4. Okay? So yan. So dito, ang ginamit ng designer, ang ginamit ng designer is where is that? Ayun. Is 0.5, 0.05 plus 0.05 is 0.1 plus 4 of 0.1, that is 500. Okay? So hindi natin kasi sure ito yung 1/6 of the clear height because we have the wall footing. But you can check it later on, no? When you're already computing it. Now, what I'm trying to point out is, dapat, if magkakaroon ng splicing, the good thing about here for the first floor, we do not have any splicing. Ano ba yung splicing natin? For example, nag-stop na yung floor natin. Nag-stop na yung bakal natin at this point. Kailangan nating dugtungan yan. Now, if idudugtong natin yan, hindi yan pwedeng ganyan na idudugtong. If we're going to do that, if we are going to connect them, dapat merong konting space na magmi-meet sila. Okay? Then dito natin sila itatali. This is what we call splicing or overlap or lap. Okay? Yan. Now, it is recommended, okay, or dapat, yung splicing natin mangyayari dito outside of the confinement zone. Okay? Dapat dito mangyayari yung splicing. Now, sir, bakit yung dowel bars natin 0.4? We use 0.4 and ang sabi dun sa suggestion or ang sabi dun sa notes, use 0.4 meter here. Okay? I am showing you this because this is already a practice, somehow a practice in the construction industry for residential building. Okay? Kasi yung 0.4 na yan, medyo malaki-laki na yan. Okay? And actually, yung iba 0.3 pa. Okay? Now, I am explaining this to you so that if you will be practicing already, magamit yung theory. Okay? So, what we're trying to say here is we want to avoid our splicing between this zone. Okay? Or within this zone. Okay? So, yan. So, as much as possible, dapat dito tayo mag-splice. And, we're not yet done. Let's say we have here a splicing. For splicing, we are going to use 0.6 meters. Ano yung 0.6 meters? Though, take note ha. This has reference with respect to your NSCP. May mga code yan. Etong mga ginagamit natin dito na dimensions are in conformity with the code. It's just that nag-i-excess tayo para mas madaling i-solve. Okay? Or madali siyang i-estimate. So, yeah. So, for example, ito yung isang bar and ito yung isang bar. Ipagdudugtong ko yan, dapat yung space between this end and this end should be 0.6 meters. Okay? Try nyo, if you're going to compute this based on the NSCP from your reinforced concrete, mas ano pa siya, mas mababa. Okay, so we are on the safe side. Okay, now for example, we have here splicing. Nagkaroon tayo dito ng splicing. Meron ulit provision. Okay, meron ulit provision from the NSCP yan. Okay, may spacing tayong sinusunod. Now, I will not be encroaching with your reinforced concrete, but we are going to adopt yung maximum from the ACI, American Concrete Institute, na 0.1 meter spacing. So, magkakaroon tayo dito ng 0.1 meter. So, lateral ties, 0.1 meter spacing, 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 lateral ties. Okay? Yan. Now, if nandito ka naman sa junction between the column and the beam, again, meron din ulit provision yan from the code. But we are not going to encroach with that. Ang gagamitin na nating spacing pag nandito ka na, nakatapat ka na sa beam, would be a spacing of 0.1. So, yan. Spacing 0.1, spacing 0.1, spacing 0.1, then spacing 0.1. Then babalik ka na sa point sa confinement zone. Okay? So, with that being said, these things must be taken into consideration with respect to estimating your reinforced steel bars. Okay? What if na-encounter nyo naman, sabihin natin, nasa second floor tayo. At this one, this is not a footing, rather a beam. Then, we also have here a beam. Then, from the bottom of the beam and the top of the beam, yun yung i-consider nating height if it is beam to beam. Okay? So, yan. Next, we proceed with the next computation. Okay, so we have here the beam. So, for the beam, we are going to refer to our plan. Now, para mas maintindihan natin for this, for estimating for the reinforcement on the beam, I am going to use this section. Okay, so we have here grid C from 6 to 8. Okay, so ito yung i-estimate natin. Now, what are the things or what are the factors that needs to be considered in terms of estimating for the steel reinforcement for the beam? Okay. Now, for the beam, we have the main reinforcing steel bar and we have the stirrups. So, ito yung main reinforcing steel bars natin. We have this 1, 2, 3, 4, 5. Then we have here the stirrups. Okay. Now, for the column, we have the lateral ties, but for the beam, we have the stirrups. Okay? So, for example, we have here an end or discontinuous beam. So, we have here an end span. Okay? So, ang mangyayari dyan, magkakaroon tayo dito ng bend. Okay? So, bend. So, by the way, in your reinforced concrete, you're going to compute for the length of the bend. But again, since nandito tayo sa estimation natin or sa estimates, we are not going to encroach with your reinforced concrete. Rather, we are going to use values that are safe and in conformity with the NSCP provision. Okay? So, we have here the bend, the length of the beam, the column, then yung width ng column, plus the concrete cover. So, paano yung mangyayari dito? Now, if we're going to consider this beam, the length is 8.5 meter. Ito, this one is 8.5 meter. Now, hindi dyan nag-start yung reinforcing steel bars natin. Mag-start yan sa may mismong column because it needs to be anchored. Okay? So, in order to do that, we first need to consider the length of the beam, the length of the bend, yung length ng bed, plus the length ng beam, plus the column width, idadagdag natin yung column, saka natin isusubtract yung concrete cover. Therefore, nakuha natin yung length ng bend, yung length ng reinforcing steel bar kasama yung sa column, papasok siya sa beam, lalabas sa column, magbe-bend siya. Okay? So, yun yung total na kukunin natin. That is for the continuous top bars. Now, if it would be the discontinuous cut bar, ito, discontinuous cut bar, take note, paano ba lang natin malalaman kung anong continuous at saka yung cut bar. Let's just consider the section. Okay, so at the support, we have here 1, 2, 3, 4, 5. We have 5 steel bars, okay, main reinforcing steel bar. But at the mid-span, bibilangin natin, we only have 1, 2, 3, 4, 5. But this time, sa top bar, tatlo dito, dito naman dalawa, bottom bars. Sa mid-span, dalawa yung sa top bars, tatlo yung sa bottom bars. Okay? So, dito malalaman natin na sa top bars, we only have one discontinuous or cut bar. Now, for the mid-span, we have here the cut bar na iisa sa baba. Okay? Bakit ganon? Now, if we are to imagine the moment diagram of this beam, ganito kasi itsura nung ng moment diagram. Okay? So, if we are to base it on the moment diagram, yung tension side on this area is it's on the upper part. Okay? Now, the tension side on the midspan, nasa ilalim. That's why there is no sense if we are going to place a additional reinforcement sa taas since the tension is at the bottom. Okay? And dito rin sa kabilang end span, yung tension natin is nandito sa taas. That's why we are placing the reinforcement sa taas. That is to counter the tensile force. Okay? So with that being in mind, take note for the top bars, yung additional reinforcement natin for or yung cut bar natin, it should be exceeding the L/4 distance. Okay? I repeat, you have a computation for this in your reinforced concrete, but we are not going to encroach. Okay? But yeah, for the cut bar on the top bar, dapat hindi lang naayos yung pagkaka-draft. Ito dapat is lagpas siya sa L/4. Likewise with this one, lagpas dapat siya sa L/4. Okay? Then for the bottom discontinuous bar, which is this one, it should be L/5 and L/5. So dapat eksakto or labas siya sa or pasok siya sa L/5. Okay? So that would be the length of the discontinuous bottom bar. Okay? So with that, we can now estimate. So considering this, we are going to estimate this portion here. I'll be showing you what if tumama siya sa column. Pag tumama siya sa column, yan, papakita natin dito. Dito kasi, the reason why we are not considering this for our example, kasi wala na, hindi siya tuloy-tuloy or hindi siya continuous beam. So dito we have a continuous beam here. Okay? So and dito yung end span. Okay? So we consider this, and the length of this is, we have 2.95, but the 2.95 here is on the edge. Okay, so 2.95, while the 2.8 here is on center distance. Now we know that this is 0.4, so we're going to subtract 0.2 here. Okay, because we're only interested in the length of the beam here. But if we are going to estimate it, dapat tuloy-tuloy ito dito. But on our end, let's say dito tayo mag-end. Okay? So the distance is equivalent to 2.95 plus 2.8 minus No. Ganito na lang gawin natin. Sige. Let's consider this part. So, we have here. Okay, now for the bend, okay, let's start with the bend. Now for the bend, what the length of the bend that we are going to use for the top bars, for the top bar, would be 0.6 meter. Okay? So 0.6 ang gagamitin natin. Take note, I repeat, meron yan sa RC nyo, makakompute nyo yan, but in our case, we're going to use 0.6 meters. So 0.6 meter, don't worry, this is safe with respect to the NSCP provision. Now for the length of the beam, dediretso tayo. So 2.5 up to 2.8. Dediretso natin hanggang sa 2.8 plus i-add natin itong column. Let's say na dito tayo mag-i-end sa column na to. Okay? So that is 2.95 plus where's that? 2.8. So that is 5.75. Now take note, dito nasama na natin yung column. Okay? But if we are to remove the column, ibawas natin si column, minus 0.4, minus 0.4. Take note, dito tayo nag-end. Okay? So, minus 0.8. That is 4.95. So, the length of the beam is 4.95. Now, why am I saying, bakit sir hindi natin binawas yung length ni column dito, which is another C1? Because the reinforcement will go through the beam. Dadaan siya dun sa beam. That's why we are counting it. Dito kasi, diba? Pinakita natin na sa column, dadaan siya sa column. That's why we are adding the column here. But since it is a continuous beam on this one, i-add natin si column. Hindi na natin siya isusubtract. Okay? Now, for the column width, ito yung column natin. So, i-add natin si column dito, which is 0.4 plus 0.4. Okay? So, that is 0.4 meters. Now, for the concrete cover, ibabawas natin is 0.04 meters minus 0.04 meters. So, 0.04 times 2. And that is in meters. Therefore, the total length of your reinforcing steel bar is 0.6 plus 4.95 plus 0.4. And yung concrete cover is to be subtracted kasi ibabawas natin yung space ng concrete cover. It is not addition. So, it is minus. So, minus 0.04 times 2. And that is equivalent to 5.87 meter. So, 5.87 meter. Now, bakit tayo mag-multiply ng 1.1? We are going to multiply 1.1 because there might be splicing or there will be splicing along the end. But in this case, no. Kulang. Kulang yung bend. It should be times 2. Why? Kasi, magbe-bend tayo dito pababa, magbe-bend din tayo dito pababa. So, we are going to bend here downwards and bend here downwards. So, isang tuloy lang dapat yan. Okay? So, times 2. So, 5.87 plus another 0.6. So, that is 6.47. So, mali. So, this is 6.47 meters times 1.1 because it is for splicing. So, times 1.1. So, that is 7.117. Okay? Now, in this case, if ang ginagamit natin is 6 meter commercial length, so sobra na si 6 meters. Okay? We have two options. Pwede natin gamitin si 7 meter commercial length, si 7.5 meter commercial length, or pwede natin gamitin pa rin si 6. If we are going to use 6, definitely, kailangan natin multiply ng 10%, ng additional 10%. But if we are not going to use the 6 meter, rather we're going to use the 7.5, pwede na tayong hindi mag 1.1. Okay? But since ang ginagamit natin dito is si 6 meter commercial length, we are going to use additional 10%. Okay? Now, take note na hindi ka pwedeng magkaroon ng splicing dito sa L over 4. Okay? Definitely, mas mahaba sa L over 4. Dapat nandito yan. Sa L over 5, nandito yan. Okay? You cannot have your splicing inside the L over 4. So, dapat, if ganito yung case mo, si 6.47, pwede mo na siyang ikat along sa gitna. Okay? Pwede mo siyang ikat sa gitna. But in this case, dito, hindi ka pwedeng mag-cut dito kay, hindi ka pwedeng mag-cut dito sa, dito, L over 5 between SB and L over 4 between SB and L over 4 between SB. Okay? So, hindi, dapat yung splicing natin nandito sa gitna. Or more or less, nasa labas ni L over 4. Okay? So, that is 7.17 meters. So, ilan ang magagamit natin continuous bar dito? We will be using 2 pieces. Bakit? 6 pieces divided by 2. But what we are pertaining here is the pieces of continuous top bar is hindi yung dami per isang piece or per isang length, no? Ang hinahanap natin dito is the pieces per continuous top bar is ito. Ilan yung continuous top bar natin? Okay? So we are going to base it sa schedule. So from the schedule, we have here ang top bar lang natin na continuous ay dalawa. Bakit? Kasi sa midspan, dito sa gitna, dalawa na lang yung top bars natin. Therefore, ang continuous lang natin ay dalawa. So, we have 1, 2. So, 2 pieces continuous top bar. Okay? We only have 2 pieces continuous top bar. So, going here, we have here 7.117 meter. So, we have here 7.117 meter divided by 6 meter per piece. This is the commercial length natin ng RSB. So, 6 meter yung haba niya kada piraso. So, ilang piraso yung kakailanganin natin. So, we have here 7.117 divided by 6. And that is equivalent to 1.186 pieces times 2. So, 1.186 times 2. Bakit natin ita times 2? We have here 2 pieces continuous top bar. Okay? So, that is equivalent to 2.372 pieces. So, we place here 2.372 pieces of D16mm. Now, are we done? We're not yet done. Why am I not rounding off? Kasi meron pa tayong discontinuous bar. Okay? So, take note, isang ano pa lang yan. What we have computed is just for the continuous top bar. Meron pa tayong we have continuous bottom bars pa. Meron pa tayong bottom bars and meron pa tayong discontinuous top bar and bottom bar. So now let's proceed with the discontinuous cut bar. Now for that discontinuous or cut bar, which is on the top bars, same pa rin. Okay, so we have the bend here. So we have the bend here of 0.6. So 0.6 meters. Now take note for for this one, since this is an end span, ang i-consider lang natin is nasa isang side lang siya. But if it is on a continuous beam or continuous span, which is like this, okay, iba naman yung magiging computation natin. Okay? Pakita muna natin yung isa. for end span. Okay? So for end span, we have 0.6 plus the column width. Isasama natin yung column natin. So the column width here is 0.4. Dito kasi yan, ito yung top view niya. So 0.4. Dito siya tatakbo. So ito yon. So the width of the beam is 0.4. We have here 0.4 meters. Okay. Now for the concrete cover, we're going to use 0.04 meters. Isa lang kasi sa side lang naman na to. Then for the L over 4 of the beam, ito yung beam natin, di ba? The span of the beam is 2.95. Beam lang kino-consider natin, the clear span. Okay? So 2.95 minus 0.4 kasi this grid C8 is on the edge. Okay? So ibabawas natin yung buong column minus 0.4. Then yung C7 is on center. So ang ibabawas natin is half of the beam minus 0.2. Therefore, the clear span is 2.35. Okay? So 2.35 lang tayo. Okay? To visualize it more clearly, ayan. Nag-drawing tayo ng mas naka-zoom. So this one, ito. This one is this one. Itong column dito is the column here. And the column dito is the column here. Now the clear span here is 2.35. So this is 2.35. Okay. Now we need to consider here the L over 4. So dapat hindi siya lalagpas, dapat hindi siya iiksi sa L over 4. So this is L over 4. And L over 4 is equivalent to 0.588 meters. Okay? And this is also L over 4, 0.588 meters. Okay? So, ang itsura kasi niyan, nung discontinuous bar natin is ganito. Okay? So, pag ganyan ang itsura niya. So, the bend here, ito yung bend natin. This is 0.6 meters. Then, we have here the column minus the concrete cover plus the L over 4 plus 0.14 the hook. Okay? So, that is 0.1 meter. So, yung length ng ano natin, yung length ng ating discontinuous bar or the cut bar is, okay, isa-isahin natin. We have the 0.6 plus the column width. Ito, column width natin is 0.4 minus the concrete cover plus L over 4. Plus L over 4. What is our L over 4? 0.588 meters. Then, the hook which is 0.1 meter. Therefore, ang total niya is equivalent to 0.6 plus 0.4 plus 0.04 plus 0.588 plus 0.1. 1.728. So, that is 1.728 meters. Bakit hindi tayo nag-multiply ng times 1? Kasi hindi naman tayo mag-splice. Dapat magkadugtong yan. It should not be spliced. Okay? So, bakit na natin sinulat? Dapat dito. So, 1.728 meters. So, 1.728 meters divided by 0.6, divided by 6 meter per piece. Definitely, that is below 1. So, that is 0.288 pieces. Okay? Isa pa lang yan. Okay? Now, that is just for this end here. Now, take note, itong side na to, iba na naman yung kanyang clear. clear distance. Okay? Ano yung clear distance niya? From the plan we have 2.8. It is 2.8 minus 0.4. No, it's 0.2 lang kasi on center to. Then this one is also on center. So 0.2 minus 0.2. So the clear distance or the clear space, the clear distance or the unsupported length, 2.8 minus 0.4. And that is 2.4 meters. And yung L over 4 natin dito, ay magkaiba. Okay? Now here, we have 2.4 divided by 4, that is 0.6 meters. This is 0.6 meters. Now, ang mangyayari naman yan, ang itsura nung discontinuous bar natin is pag ganito siya, magkakaroon pa rin siya ng bend, which has a depth of 0.6 meters. Okay? 0.6 meters. Then we have here the hook. Okay? So for the end, this is that is C8. Okay? So this is C8 here. Then sabihin naman natin we have C7. No, that's not C7. C6. So let's say this is C6. Okay? So ito si C6 natin. We have C6. Okay? Nandito tayo kay C6. Pag ganito. So the bend is still 0.6. The column width is the same. That is 0.4. Then the concrete cover is the same, 0.4. Ito yon, 0.6, 0.4. And this one is the same, 0.4 meters. Okay? Now, dito na tayo kay C6. Now, concrete cover L over 4 is 0.6. Okay? And the hook is the same, 0.1. Therefore, yung total naman nito is 0.6 plus 0.4 plus 0.4. No. 0.04. Plus, it should be minus. Wait. Did we add the concrete cover here? Mali. It should be subtracted. Wait. We have 0.6 plus 0.4 minus 0.04 plus 0.588 plus 0.1. 1.648. 1.648. So, mali ito. This should be 1.648 divided by 6. So, that is 0.275. Now, itong C6. Si C6 naman, we have 6 plus 6 plus 0.4. No. Minus the concrete cover plus 0.6 plus 0.1. We have 1.66. Now for the 1.66 divided by 6, we have here 0.277. 0.277. Okay? Next, yung sa gitna naman. Consider natin yung sa gitna. Yung sa gitna, we have C7. Okay? Ito naman. C7. Which is this one. Okay? Okay. Now, for that, ang magiging itsura ng discontinuous top bar natin is ganito. it will pass through the beam or the column rather. So ang magiging length lang niya is L over 4, which is 0.588 plus the beam, which is 0.4, plus 0.6, which is L over 4, plus dalawang hook, plus 0.1 plus 0.1. And yan yung kanyang length, 1.788 meters. Okay? So, lalagay natin sa column width, same, we have 0.4, wala tayong bend, wala rin tayong concrete cover. L over 4 is 0.588 plus 0.6. Now for the hook, that is 0.2. Okay? Therefore, the length is equivalent to 1.78 788 divided by 6. So this is 2.9 at no 0.298 0.298 plus 0.277 plus 0.275, that is 0.85. Now, what is 0.85 ng isang 6 meters? So, times 6, that is 5.1. Now, if yung cut bar natin, matitira dito is 0.9 meter. Itong 0.9 meter na to, wala tayong mapaggagamitan. Like for example, sa bottom bars naman, walang 0.9. Ang i-round off na agad natin to sa 1. Okay? Pag hindi natin magagamit yung 0.9. But if we can use the 0.9 here, okay? Pag magagamit natin tong 0.9 here, which is titignan natin kung magagamit, then we can use the decimal. Okay? Very specific kasi yung cut natin. So 1.647 plus 1.66. So 1.66, 1.648 plus 1.66 plus 1.788. Ayan. So, i-round off natin yan into 2 decimal lang. Magiging 1.65 plus 1.66 plus 1.79. Okay? So, that is 5.1 meters. Yung 0.9, if pag may paggagamitan, we can use the decimal. If we cannot, or if we can no longer use the 900 mm na haba, then we are just going to round it up na to 1. Okay? So, yeah. Okay. So, this is 0.85 pieces. Okay. Now, for the bottom bars naman. Now, if you're curious kung anong itsura nung top bar natin na continuous, same. Ganito rin siya. Naka-bend siya dito. Then, it will go through here. Then, dediretso siya dito sa dulo. Okay, dediretso siya pag ganito. Tapos magbe-bend din tayo dito pababa. Okay, so ganyan yung itsura niya. Now for the bottom bar, continuous naman. Magbe-base pa rin tayo dito sa section natin or sa schedule. Now from the schedule, if you're going to see from the at support, so ito yung support natin, ito yung midspan. So, sa support natin, dalawa yung merong bottom bars. Now, at the midspan, meron tatlo na siya. So, ibig sabihin, nadagdagan tayo ng isang bar sa midspan. Okay? So, ang continuous lang natin ay dalawa. So, we have 1, 2. Okay? So, dalawa lang siya. So, with that, dito na tayo sa continuous bottom bars. So, for the continuous bottom bars, ang gagamitin natin dito is the depth of the beam for the bend. Now, what is the depth of the beam? The depth of our beam is 0.4. Tama? So, ang gagamitin natin dito is 0.4. Now, for the column width, the width of the column, same. Ganun pa rin. Okay? Pero para mas ma-imagine nyo, ganito kasi magiging itsura niyan. Magbe-bend siya pa ganito. Then it should go straight here. Okay, so yan. So we have 0.3 plus yung column, then yung beam, then column, then yung bend. Then subtract natin yung concrete cover. Okay, so balikan natin to. We have here the bend is 0.4. The column width is 0.4 plus 0.4, so that is 0.8. Parang may mali tayo. Bakit isang column width lang ang kinonsider natin dito? It should be 2. Kasi dalawa yung kanyang dinaanan. Pinagbend. Okay? Mali. This should be times 2. So, ang lalabas dapat dito is 0.6 times 2 plus 4.95 plus 4.4 times 2 minus 0.04 times 2. 6.87. 6.87 times 1.1, 7.557. So, 2 pieces, parehas. Okay, so dapat maging careful kayo, no? Tignan nyo. Medyo mabusisi ang estimating ng steelworks. So, 7.557. So, 7.557 divided by 6. So, that is 1.26. 1.26 times 2. That is 2.519 pieces. Okay? So, mali. Okay. So, balik na tayo dito sa bottom bars natin. We have 2. So, kasi dalawa yung dinaanan yung column for the Kasi dito, hindi na, kinonsider na natin to na length ng beam kasi dediretso siya pa ganyan. Okay? Tapos, we have length, column beam, length ng beam. Anong length ng beam natin? Same. We have 2.35 plus 2.4 plus 0.4. Ito yung 0.4 na yun. So, that is 5.15. Bakit? Okay. So, yeah. Tama ba? The clear. Wait. So, that's 2.8. That is 2.95 minus 0.4 minus 0.2. 2.35. Tama. Plus 0.4 plus 2.4. So, 5.15. So, we have here, length of the beam, we have 5.15. Then, for the concrete cover, dalawang concrete cover dito, at saka dito. Okay? So, 0.04 times 2. Now, for the total length, we have 0.4 plus 0.4 times 2 plus 5.15 minus 0.04 times 2. So, this is equivalent to 6.27. Okay? So, 6.27 times 1.14, the splicing, is equivalent to 6.897. So, 6.897 divided by length per piece. So divided by 6, so that is around 1.15 pieces. Okay? Okay, so this is 1.15 pieces. So 2.519 pieces. Okay? Now, for the bottom bar of the discontinuous, for the discontinuous bottom bar or the cut bar of the bottom bar, ito naman siya. Take note, like what we have said kanina, yung itsura ng kanyang moment diagram pa ganyan. That's why, for yung tension natin on the midspan, nasa ilalim. So, ang malalagyan lang dito ng bottom bar is ito. So, ganito kanyang itsura. Okay? Okay. So, ang magiging length niya is clear span minus L over 5 because this is L over 5 and this is also L over 5. Okay? So, yung clear span natin na 2.35, what is our L over 5? 2.35 divided by 5, 0.47. So, this is 0.47. This is also 0.47 meters. Okay? So, yung length niya, if babalik tayo dito, yung length ng beam natin is 2.35. Then, yung L over 5 natin is 0.47. And this is times 2. So subtract natin. So, subtract siya. Then, for the hook, we have 0.1 and another 0.1. So, we have here 0.1 times 2. Therefore, the total length is 2.35 minus 0.47 times 2 plus 0.1 is equivalent to 1.61 meters. Now here again, we're not going to multiply it by 1.1 because we should not have a splicing for this. Hindi dapat tayo magkaroon ng splicing para dito sa discontinuous bottom bar. Okay? Now this is for C ano to? This is C7, this is C8, and this is C6. Okay? So, C7 to 8. So, yeah. So, this is C7 to C8. Ito naman C6 to C7. Okay. But before we proceed with that, we have here 1.61 divided by 6 meters, which is the commercial length. That is equivalent to 0.268 piece. Okay, dito naman tayo kay C6 to C7. Ito yon. So, ang clear span natin is 2.4. Now, L over 5, so L over 5, that is 2.4 divided by 5, 0.48, 0.48. So, yeah. The length is 2.4. Then, L over 5 is 0.48. And that is again times 2. Then, that is subtraction. Then, the hook is 0.1 plus 0.1. Okay? So, the total length is equivalent to 2.4 minus 0.48 times 2 plus 0.2. That is 1.64. 1.64 meters divided by 6. That is 0.237. 0.237 pieces. Okay? So, we have here Okay, check na natin. Kasi tapos, assuming na-solve ko na lahat ng aking D16. Because for the stirrups, ang gagamitin natin dito is, I think, D10 from the plan or from the schedule. Okay, yeah, stirrups is D10 mm. Now, here, our main reinforcing steel bar is D16. Okay? So, what is 0.59? 0.59 pieces. So, 6 times 0.59. That is 3.54. Okay, so 3.54. So, pwede nating ipag-add. Kasi yung cut, ang kino-consider natin dito is yung cut. So, pwede si continuous bar. Ang kailangan natin dito is 2.37. So, 2.68, 0.268 plus 0.237, we have 0.505 pieces. Okay, pwede natin nang ipag-add. Okay, that is for the bars, the discontinuous bar. What is dito, pwede natin isama kasi 0.9. Check na natin if hindi na natin magagamit si 0.9 dito sa bottom bar. Kasi ang matitira kasi dito is 0.9 meters. Now, dito naman sa discontinuous bottom bar, it is 1.64 plus 1.61 meter. 1.64 plus 1.61 meters. So, si 3.25. So, may excess din tayong 2.75. So, definitely we need to round it off na. Dito na tayo magra-round off ng mga whole value. Dito kasi sa top bars, meron tayong splicing. Okay, meron tayong splicing. So, pwede natin idiretso yung mga decimal, ipag-add-add. Now, dito sa bottom bars or sa discontinuous bars or sa cut bars, wala tayong splicing. So, we need to consider kung i-round up na ba natin siya into whole. Okay? So, dito, wala tayong paggagamitan ng 0.9, i-round up na natin siya sa 1. So, dito sa cut bars naman, we have an excess so 1 piece lang siya. Okay? Isang diretsong 6 meter. Meron tayong sobra na 2.75 meters. So, wala naman tayong paggagamitan. Hindi naman tayo makaka-order ng 0.35 meters. So, i-round up na natin siya sa 1. Okay? So, this should be rounded up to 1. Take note, wala kasi tayong splicing dito. So, this is equivalent to 1 piece. And this is also equivalent to 1 piece here. Okay? Or pwede nyong gawin is, for example, this one. This 1.66 or 1.67, may sobra tayo dito na 2 point something, di ba? So, 6 times 0.505, so that's 3.03. Tama ba? 2.68 plus 2.37. Okay, 5.05 meters minus 6. Wait. 6 minus 1.64 minus 1.61. That is 2.75. Okay, so we have an excess of 2.75 meters. Now, itong either 1.66 magfi-fit dito. Magfi-fit pa rin yan pag kinat mo or yung 1.77. Okay? Then, yung matitira, yung isa sa kanila, try nyo din hanapan kung pwede pang mag-fit. So, we can remove this or maibawas natin. Okay? Mabawasan natin yung excess natin. Okay? But for, like what I've said, yung mga 1.1, then we can round it na. Or we can use the decimal value of this since we have the splicing. Okay? So, here, we have no choice. Magiging dalawa talaga sila. So, 1 piece plus 1 piece. Kasi walang pagfifitan yung ito. Kasi i-total natin yung continuous bar. Yung continuous bar natin is 2.519 plus we have 1.15. So that is 0.669. So 0.669 of 6 meters is 4 point, pwede. 4 point, 4 point something meters. Itong isa magfi-fit na dito. Then itong isa magfi-fit na dito. Magfi-fit na siya dito. Okay? Now, kung papansin ninyong maigi, okay, try natin ha. Let us just try. So, you have here 2.519 plus, for the continuous bar, we have 1.15 plus 1.15. Tapos sa discontinuous, we have 0.85 piece plus 0.85 plus sa bottom bar demand dito, we have 0.505. 0.505. And that is equivalent to 5.024. And that would be rounded up to 6 pieces. Okay, 6 pieces yung gagamitin. Now, let's check naman if we're going to consider for the separate. Okay, kung consider natin yung separate. Now, for the continuous bar, ipag-add natin yung continuous bar, 2.519 plus 1.15 pieces continuous, 1.15. So that is shift store A, that is 3.669. So 3.669 magiging 4 pieces yan, definitely rounded up to 4 pieces. Now this is 1 piece kasi 1.67, 1.66, 1.77, kahit na i-transfer natin dito, i-transfer natin yung isa, may excess pa rin na, kakailanganin pa rin natin dito ng isa. Like for example, this is 0.275, di ba? 0.505 plus 0.275, that is 0.78. So, hindi na tayo pwedeng mag-add either ito or ito. So, definitely, this is one piece, this is another piece. Okay? So, ang total pa rin, 1 plus 1, 2, plus 3.66. 3.66 is 6 pieces. Okay? Now, for our sake, for computation sake, ang gagawin na lang natin, we are now going to consider the decimal places on either which of the bar. Now, why did we went through the process, no? Kung decimal lang naman din pala yung consider natin. I want to point out na dapat be careful in estimating the discontinuous bar or yung cut bars natin. Okay? Make sure na no splicing ang mangyayari. Okay? There should be no splicing. Okay? Okay, now for the stirrups, let us continue. For the stirrups, we have here this span. Okay, now according to the schedule, may schedule tayo which is eto. According to the schedule, 2 at 0.05, 10 at 4 at 10 meters, 0.10 meters. Rest is 20 meter on center distance. Okay? So, actually, parehas lang naman yung katulad kanina. Katulad kanina sa column. Okay? So, if we are going to do that, we have here space, 0.5, space, 0.5. So, dalawa na siya. Then, space, 0.1, space, 0.1, space, 0.1, space, 0.1. So, 1, 2, 3, 1, 2, 3, 4. Then the rest is at 200. Okay? So, ganyan din siya. So, kung ano yung spacing dito, yun din yung spacing natin dito. So, 2 ways. Okay? So, gagawin natin, yung clear length or yung unsupported length natin, which is 2.35 face to face of each column. Okay? So 2.4 or 2.35. So for the length of the beam, it is 2.35. So 2.35 divide natin sa 2 because we have here yung central line natin. So we have here our central line. So kung ano yung spacing dito, yun din yung spacing dito. Okay? So 2.35 divided by 2, we have 1.175. Now for the number of stirrups at 20 meter on center spacing. So 20 meter on center spacing, ito yun. And that would be, we have here 1.175. So 1.175 minus, from the schedule we have here 0.05, dalawa. So minus 2 of 0.05 minus 4 of 0. 4 of 0.1, and the rest is 0.20 meters. Okay, so the number of stirrups here is equivalent to 1.175 divide minus 2 times 0.05 minus 4 times 0.1 divided by 0.2. So that is equivalent to 3.375. Okay? But there is no such thing as 0.375. So this would be rounded up to 4 pieces. Okay? So the total number is, we have here 2 plus 4. So 2 plus 4 plus 4 times 2. Kasi both ways. Okay? BW. So dito, both ways siya. So times 2 plus, times 2? No. Times 2 minus 1. For the column, ang ginawa natin, nag plus 1 tayo. Now for the stirrups, magma-minus 1 naman tayo. Okay? So this is equivalent to 2 plus 4 plus 4 times 2 minus 1. That is 19 pieces. That is the total number of stirrups. Okay? But how can we proceed kung hindi pala natin alam ulit yung length ng stirrups natin? Okay? So for the length of the stirrup, what is the perimeter of the beam? The perimeter of the beam, take note, it is SB and the PB. Okay? So for SB and PB, 0.4, 0.2, 0.2, 0.4. So parehas. So with that, it is 0.2 times 2 plus 0.4 times 2 minus 0.1. Therefore, the length of stirrups is, I think it's 1.1 din. Yeah, dapat. 2. So yeah, 1.1 meter. Okay? So the number of cut per PSB, ilan yung makakat natin na 1.1 meter sa isang 6 meters? So 1.1 divided by 6 divided by 1.1, that is around 5.45. 5.455. So ang i-add up lang natin is the whole number, so that is equivalent to 5 cuts per RSB. Now, for the number of RSB, it is equivalent to the number of ties. Ilan yung number of ties natin? We have 19 pieces. So, that is equivalent to 19 pieces times the length of tie per piece, which is 1.1. divided by the number of cuts per RSB. So that is equivalent to 19 times 1.1 divided by 5. That is 4.18. But there's no such thing as 8.18 na 6 meter length. So we rounded up to 5 pieces of D10M M6 meters. Okay. Now for the tie wires, same. Okay. So it is the length of the tie wire that we're going to adopt is 0.3 meters. Okay. Then per kilogram we have 53 meters. So how many intersections do we have? So here we have 1, 2, 3, 4, 5, 6. Dito naman 1, 2, 3, 4, 5, 6. Okay? So lima yung ano natin, lima yung intersection natin with the beam with the stirrups rather. Wait, let me just focus. Okay. So we have 1, 2, 3, 4, 5 para dito sa isang hook, then for the another hook pang 6. So there are 6. Then how many number of lateral ties? We have 19. So 6 times 19 times the length of tie wire 0.3 meters. So 6 times 19 times 0.3, and that is equivalent to 34.2 meters. 34.2 meters. So 34.2 meters times 1 kilogram is 53 meters. So cancel yung meters divided by 53. That is 0.645 kilograms. Okay? So ito yung mamaya pa tayo mag-round off pag natapos na natin yung lahat. Okay? Now, yeah. So, are we done here? Not yet. Why? Because we still have the slab. Okay? Malabo. Ayan. Okay, so we still have the slab. Before we proceed with the slab, we just have to check first, no? Check first for the splicing. Kasi kanina sabi natin sa column, if it is a column and nagkaroon ng splicing, definitely mag-iiba yung ating what do we call that? Mag-iiba yung ating spacing. Okay? So let me show you if nagkaroon tayo ng splicing. Okay? So let's say dito yung splicing natin. If on this side, nagkaroon tayo ng splicing, let's just say, nagkaroon tayo ng splicing dito. I will just show you. The spacing here, let's say the spacing here is 150 mm on center or 200 centimeter on center. Now, since we have a splicing here, may splicing tayo dito, mag-iiba yung ating spacing. Magiging 100 maximum 100 mm on center distance yung gagamitin natin. Again, this has something to do, or this is in conformity with the provisions from the NSCP. So merong computation yan. Pero ang maximum na sabi ng ACI is 100 mm. Okay? So the spacing is 100 mm on center maximum according to ACI. But then again, you can compute this from yung spacing natin dito can be computed from the NSCP. Okay, so binibigay yan ni NSCP. So if that's the case, nagkaroon tayo ng splicing, liliit yung spacing natin. Then mag-iiba yung ating estimate for the steelworks. So definitely madadagdagan. Okay? Okay, so now dito, for example, yung nakuha natin dito is 6.7. Am I right? 7.755. Now, what I'm going to do yung 7.55 na yun is from here hanggang dito, tama? Yung splicing ko, dito ko siya gagawin. Okay? So, dito ako magkakaroon ng splicing. And since dyan ako magkakaroon ng splicing, mag-iiba yung spacing ko ng stirrups dito. So, definitely, I need to consider this. Okay? So, that would be your practice for your upcoming activity and quiz na dapat i-consider mo yung splicing mo dito sa labas or sa gitna, sa midspan, labas ng L over 4, labas ng L over 4. Okay? Yan. Tapos, from there, magtutuloy tayo pababa. Okay? So, let's now proceed with slab. So, for the slab, unlike the footing, column, beam, we use the direct method or the counting method. Now, for the slab, what we're going to use is the area method. So, when we say area method, we're just going to compute for the area, then multiply it with our factor. Okay, so this is our factor. So, this is for a one-way slab, and this is for a two-way slab. Okay, now, in doing so, what are the things that needs to be considered? Okay, so for example, we have here my second floor framing plan. I am going to base it here. Okay, so ang gagawin ko, i-compute ko yung area. But what area should we consider? Should I consider the gross area or should I consider the net area? Okay, so in computing for the area, we are going to consider the gross area. Why am I saying so? This picture here is a good example of gross area. Bakit? Kasi if titignan mo, yung our reinforcement for the slab, tumagos siya sa beam. Okay? Likewise, yung reinforcement for the slab, tumagos din siya sa column natin. So, ibig sabihin, we are going to consider the gross area. So, tatagos yung reinforcement natin sa slab sa beam, yung reinforcement natin sa column. That's why it is gross area. Okay, so if titignan din natin yung ibang pictures like this one, ayun. So, this is the slab. This is our column. Okay, so tumagos siya. Okay, then, ayun. Dito yung slab natin, it is anchoring on the beam. Likewise with this one, this is your slab, this is the beam, and this is the column. So, ano siya? Mag-a-anchor siya sa beam and tsaka sa column. Okay, so going back to this plan, since hindi naman siya complicated, ang gagamitin na lang nating example is for this one. Okay, itong example na lang na to. Kasi parehas lang naman. Because, for this this video, medyo tumagal na rin kasi tayo, no? But, if we are to try it, we have here the 2.95 plus 3. Then, it is not an on-center distance. So, i-measure natin itong sobra dito. Like, for example, we're just considering this. And, si grid 4 is an on-center distance. So, that is 0.2. We know that that is 0.2. Si grid B, that is an on-center distance. So, i-offset natin ng 0.2. Then, this one is an edge distance. Okay? So, if ito yung consider natin. So, there is no complication with this. So, we can simply use this example. Now, for this example, we have here a span of 16 meter by 8 meter. And we have beams in between. So, we have here our beams and we have here our girder. So, this is a girder. When we say, when there is a girder, we can presume that the girder are carrying the weights of these beams. Okay? Okay. Now, for the slab, we have here determine the steelworks for the given beam, girder, and slab section. It is not given, we were not given the distance or the spacing rather for the slab. Okay? Now, here in our table, you are going to see that we have a one-way slab and we have a two-way slab. Now, madedetermine nyo yung one-way slab and two-way slab with the help of your reinforced concrete. So, depending on the ratio between the longest and the shortest span. Okay? But again, I will not encroach in with that. So, if sa case natin, hindi na nabigay, then you compute. Pero madali lang naman ito, class. Madali lang ito alamin if it is a one-way or two-way slab. But then again, you will be encountering this in your reinforced concrete. Now, since we do not have the specifics for this, we can go to our schedule. So, gamitin na lang natin itong area na to. Then, we can have our schedule here. Now, for the slab, ayan. So, for the slab, it is a two-way reinforced concrete slab. Okay? So, it is a two-way reinforced concrete slab. We were not given the schedule, the other specifications here. Walang binigay sa atin, but meron tayo sa mismong plano. Wait. Okay, so wala tayong nakita. So, wala tayong nakitang ibang specification unless it is a two-way slab. So, since it is a two-way slab, we are, let's use D20 mm. Or, yeah, wait. So, we assume D12 mm. D12 mm yung RSB natin for the slab. Tapos, spaced at 225 mm on center both ways. Okay? So, yung spacing natin pag ganito is 225. Yung spacing din natin pag ganito, 225. Both ways. Okay? So, first, we need to compute for the area. For the area, like what I've said, we are going to consider the whole section. Okay? Or the gross area. So, that would be 16 meters by 8 meters. So, 16 times 8 is equivalent to 128 square meters. Okay? So, the area total is 128 square meters. Now, it is a two-way slab. So, since it is a two-way slab, titignan lang natin yung spacing natin. Our spacing, this one is centimeters, this one is in mm. So, in centimeters, this is 22.5. So, dyan ang 22.5. We have here 2.756 number of bars per square meters. So, we have here ginamit natin na spacing natin is 225 mm. Then, that is equivalent to 22.5 centimeter spacing on center both ways. Then, for the number of bars, ang area natin is 128 square meters. 128 square meters times, we have here 2.756 bars per square meter. Okay, so 2.756 square meters. And that is equivalent to 128 times 2.756 over 1. That is equivalent to 352.768. So, 352.768 pieces. Pieces na to, bars na pinag-usapan nito. And this is a 6 meter by 6 meters. Okay? Of D12 mm. Okay? So, hindi lang natin to nabura. This is 353 dapat. Now, let's check. Sa mga una nating sinolve kanina, what are the diameters? So, we have D16, we have D10, and D12. Now, since we do not have other D12, what we're going to do is to round this up. We are going to round this up by 353 na. So, 353 pieces of D12 mm by 6 meters. Okay? Now, for the kilogram of tire wires, it is 353 pieces, or the square meters is 128 square meters times ilang kilogram? It is 0.202 kilogram per square meters. So 0.202 kilogram per square meter will simply cancel out. Therefore, it is 128 times 0.202. And that is 25.856 kilograms. Okay? But if you want to try to use the direct count method, pwede naman. It's just that it will be more challenging. Why? Because you need to consider here the main bars. You also need to consider here the bent bars, the cut bars, the dowel bars. Okay? So, kailangan mong i-consider yung mga yon, yung apat na yon. I repeat, you need to consider the main bars, temperature bars, cut bars or bent bars, and dowel bars. So, magkakaiba yung mga yun na i-estimate mo isa-isa or bibilangin mo isa-isa. Wherein, if we are going to use the area method, we can simply rely on the area ng ating reinforcing or yung area ng ating slab. Okay? Now, for the steelworks, we are not yet done here. Why? Because meron tayong tinatawag ng mga so, ito yung tinatawag nating stiffener. So, let's try to zoom this one. This is what we call the stiffener. Okay, this one is the stiffener, this one is the lintel beam. Okay, so yan. So, the purpose of this reinforcement is to stiffen. Okay, is to stiffen the structure. Take note, yung window natin, hindi pwedeng nakapatong lang yan sa concrete hollow block. Specifically, if your concrete hollow blocks is not, if your concrete hollow block is not, it is non-load bearing. Okay? Hindi pwedeng nakapatong lang yung frame ng bintana if your hollow block is non-load bearing specifically. So we have here our stiffener in yan. So these are your stiffeners. So we are given here the dimension for the bend of 30 centimeters. Yan. So yan. So for we have here the we have here the horizontal reinforcement, we have here the vertical reinforcement. So also we are placing stiffener sa mga pintuan before sa door jamb, because if you're just going to place your door jamb, okay, so or yung hamba ng pintuan without placing stiffener, may tendency na pag nadabog yan, pwedeng magiba. Okay, magiba yung hollow block natin. Okay, so one of the purpose of stiffener is to reinforce during impacts for impact ng pagkakasara ng pinto. That's why it's called stiffener, to stiffen. Okay, now with this in mind, we can now estimate our stiffener and lintel beam. So for example, we have here our door, no? So this is the beam. So this is the beam on second floor. This is the grade beam. So that is the grade beam. So we are going to measure our stiffener from beam to beam. Okay, so the top of the beam and the bend. So meron din tayo dito. Actually both ends yan. Okay, so yan. Now, by the way, this is the facade or the front view, no? So first, let us determine the length. So for the length of the beam, it is equivalent to, take note, this one here, the length here is 0.3 meters. So for the length, we have 0.3 And the clear height here between the beam base from our plan is 2.8 meters. Okay, so that is 2.8 meters. So L 0.3 plus 2.8 meters plus what is the depth of the grade beam? That is 0.4. Now the depth of the grade beam here is 0.4 plus the bend, which is 0.3 minus minus the concrete cover. Let's say the concrete cover here is 0.4, 0.4. So 0.4 times 2. Therefore, the length of our stiffener is equivalent to 0.3 plus 2.8 plus 0.4 plus 0.4 plus 0.3 minus 0.04. This should be 0.04 times 2. The length is equivalent to 4.120 meters. Okay? So with that, ang gagamitin natin is 6 meters. So gagamitin natin dito is 6 meter commercial length. That is just for the main reinforcement. But the cross-sectional view of that would be like this. Okay, so ganito yung kanyang cross-sectional area. So we have here the stirrups. Okay. But if we are going to see the full detail of that, naka-anchor yan, nakaganyan pa yan. Okay? Nakaganyan yan. So, nakaganyan yan dito. Okay? Now, for that, take note, itong CHB natin, interior CHB, let's say this is an interior CHB. Since it is an interior CHB, we're going to use 4 inch. Since that is an 4 inch, nakatago yan. Nakatago yung ano natin. Nakatago yung what do we say? Nakatago yung stiffener natin sa sa CHB. So, yung thickness ng CHB natin is 100 plus 19 mm for the plastering plus 19 mm for the plastering. So, the total here is almost 138 to 150 mm for the thickness. Okay? Now, what would be the length of this? The length of this stirrups is equivalent, length of stirrups is equivalent to, this is normally, since that is a 4 inch, ang distance lang nitong dalawang main reinforcing bar normally, but I repeat, depende yan sa designer. Okay, but normally, kung ano yung kapal, normally yung thickness nung ating CHB. Okay, so since this is an interior CHB, so 100 yan. So magiging length ng stirrups natin is 0.1 plus, okay, plus another 0.1, 0.1 plus 0.1 plus 0.1, and nagiging 0.3 meters yung haba niyan. Okay? Kasi magbe-bend pa yan. Okay? Yan. So with that, everything we were already able to discuss kanina, yung sa length nung main reinforcing steel bars for the stirrups. Then for the GI tie wire, dito naman yan itatali. So 1 2 1 2 1 2 1 2 1 2. Okay? So ganun din naman sa lintel beam. Now for the lintel beam, it is the one that is going to stiffen horizontally. Okay? So dito naman siya naka-position. So nakaganyan siya. But ang itsura talaga niyan pag ganyan. Nandito yung ating mga stirrups. So nakaganyan siya. Okay? So, yan. With everything said, we can now go back to our computation a while ago, and we can now compute for the kilograms of our RSB. Okay, so balikan natin yung ating footing. So for the footing, we have here 48 pieces of D16 mm. Ito rekta na to because we have a specific length here. So for D16, bilangin natin. Okay. So D16 mm by 6 meters is equivalent to, we have here 48 pieces. Tapos, for the tire wires, we have 5 point, wait, clear natin. Let's start with the footing. For the footing, we have D16 mm. We have 48 pieces. For the GI tie wire, we have, ilan yan? We have 5.434 kilograms. Okay. Now for the vertical reinforcement, we have here the vertical reinforcement for the column. Yung mga na-compute lang natin, ha. Let's say ang gamitin natin si F3 kasi F3 din naman yung kinompute natin sa RSB. So ang gamit natin dito is again D16. So column. So D16 mm. Ilan ang piraso natin sa D16? We have 24 pieces. Okay. Tapos we also have our, by the way, baka may magtanong, no? Since medyo na-skip natin yung part na yon. For that, itong part na to, ito yung bend. I-check nyo yung intersection nila. Meron pa ring tie yan. Okay? Yung sa intersection, that is 0.3. 0.3 yung haba ng bend natin, which is, saan na yung bend? Eto. So, if this is the bend, ang haba niyan is 0.3. I-check nyo yung spacing. Kung ilan yung matatamaan or tatapatan ng 0.3 na bend with respect to the spacing. Pag kunyari, tatapat lang dito is dalawa, then dalawa lang yung ties. Okay? So, yung GI tie wire. So, we also need to consider that one. Okay? So, medyo na-skip lang natin, but yeah. So, let's give emphasis on that. Now, we are now on the footing. Then, sa lateral ties natin is number of D10 mm. So, we have here 29.04, but we have a, so that is 29 point D10 mm. So we have 29.04 plus for the tire wire, we were able to compute 5.23 kilograms. Then for the beam, yung beam natin, we were able to compute, we have D16. So D16 mm, we have D16 mm. Ilan yung D16 natin? We have 2.59, 2.519 plus actually, di ba, pinag-add na natin to para mas madali. 2.15 plus 0.85 plus 1.15 plus 0.505. That is equivalent to 5.024. So 5.024 pieces. Then for the stirrups is D10. D10 mm. Ilan yung D10 mm natin? We have 5. So we have here 4.18. 18 pieces. Tapos yung GI tire wires natin, we have 0.645 kilograms. Now we are done with the beam. Punta naman tayo sa slab. And sa slab, we were able to use, assuming D12 mm naman to. So we have here slab. So we have D12 mm. All of these are 6 meters, no? So D12 mm, ang ginamit natin is 353 pieces. So wala nang ibang D12 mm dyan. So we have here 353 pieces. And for the GI tire wire, it is 25.856 kilograms. Okay, so if we are going to total it, so we have here total D10 mm. We have for D10 mm 29.04 plus 4.18 and wala na. So that is 33.22 pieces. And wala namang 0.22 pieces, so we will round it up to 34 pieces. Okay? Next, we have D12 mm. So for the D12 mm, that is equivalent to, where's D12? 353 pieces. 353 pieces. Next, we have D16 mm. So D16 mm, meron pa bang iba? D16, wala na. So 48 plus column beam 24. Tama, 48, 24, 5.024, then wala na. So that is 77.024, and we can round it up to 78 pieces. Okay, now since we already have the total, we can now get the kilograms. Okay, so for the kilograms, dito we have D16 mm. So for the D16 mm, we have here for 6 meters, it is 9.47 kilograms. Okay, so D16 times 9.47 times 9.47 kilograms per piece. Okay, next for the D12 mm, it is 6 meters, that is 5.33 kilograms. So 5.33 kilograms per piece. Then for the D16, oh wait, this is D10, mali. D10 mm diameter, we have 3.70. So 3.70 kilograms per piece, and ito is 9.47 kilograms per piece. Okay? So multiply, makukuha natin yung kilogram niya. So 34 times 3.7, and that is equivalent to 125. So 125.80 kilograms. Then 353 times 5.33. So pieces will cancel out. That is 1,881.49 kilograms. Okay. Next is 77.0, 78 times 9.47. That is equivalent to 738.66 kilograms. Okay. So since we already have our kilograms here, now for the GI tire wire, that is equivalent to 5.434 plus 5.23 plus 0.645 plus 25.856. That is equivalent to 37.165. So we rounded up to 38 kilograms. Actually, may mga supplier na pumapayag na 37.5. Okay? But, yeah, we can stick with the whole number. Okay? Okay, so we can now proceed with our table. So for the table here, yeah. So we have here the table, let's say for one gang. So for one gang, we have one site engineer, we have one foreman, we have 4 skilled laborers. No, this is the days pala. Scrap this one. So one site engineer, one foreman, 4 skilled laborers, and 3 laborers. Okay. Now let's say the productivity rate or the output per day, is equivalent to 750 kilograms. So 750 kilograms per day. So 750 kilograms. Now we have here the total of 125.8 plus 1881.49 plus 738.66 kilograms. Okay. Therefore, your total quantity here is, this is just an assumption, ha? I know, not as an assumption, but it is an incomplete one kasi parts by parts lang yung kinuha natin. Hindi siya yung buong structure. So, assuming the total quantity for the structure is 2,745.95 kilograms. Okay? So, with that, for the duration is equivalent to 2,745.95 kilograms divided by 750 kilograms per day. Kilogram will cancel out, divided by 750, and that is 3.66, and rounded up to 4 days. So, ibig sabihin, yung workers mo will be working for 4 days. Okay, so from there, you can get the amount. Now, for the equipment, yan, I presented here some other equipments that are being used for steelworks. But for a small scope lang, or small project, normally we only have the bar cutter and bar bender. We also have a grinder, but if you already have your bar cutter, then we don't need the grinder. Okay? If you do not have the bar cutter, then grinder. Pero pag grinder kasi, mas matrabaho siya or mas time consuming compared to bar cutter na mabilis lang. Okay? So, let's say, ang ginamit lang natin is bar cutter at saka bar bender. So, gagamitin natin siya for 4 days. Then, ang daily rate niya is around 200 pesos. So, from there, pwede nyo nang ma-compute. Now, for the materials, kulang lang yung materials natin. because kulang lang yung nagawa kong table, because for the materials, what we were able to summarize is D10 mm. Yes, we have D10 mm. And the kilogram of D10 mm is 125.8. So, 125.8 kilograms. Then, yung number ng RSB natin na 16, D16 is 738. 738.66 kilograms. Then, kulang tayo ng D12 mm. So, lagay na lang natin dito. 12 mm RSB. Now, for the 12 mm, again, it is also in kilograms. Tapos, yung quantity natin ng 12 mm is 1,881.49 kilograms. Now, for the unit cost, yan. Magko-compute ulit tayo. Okay, so for example, for the rebar price, grade, let's say, is it specified? So let's say the price of D10mm grade 40. So D10mm by 6 meter is equivalent to 175 pesos. Pesos. Okay, so 175 pesos per piece. Okay, so the 6 meters will be divided by, the 6 meters is how many kilograms? So 6 meters divided by, how many kilograms is that? Where is that paper? Ito, so 6 meters of D10mm, 6 meters, 3.70 kilograms. So 3.70 kilograms. So we have 6 divided by 3.7, we have 1.622 meters per kilogram. Mali. Baliktad. It should be 3.70 kilograms per 6 meters. So that is equivalent to 3.7 divided by 6. So that is 0.617 kilogram per meter. Okay? Then, ang price natin would be 175 pesos per piece. So, we need to get the price of the bar per piece or per meter. So, we have here 6 meters divided by 175 pesos. So, or vice versa, we have here 175 pesos per piece. Okay? And 1 piece is equivalent to 6 meters. So, cancel. So, we are left with 175 divided by 6. We have 29.167 pesos per meter. Okay? Yan. So, we can now equate this to. So, ibig sabihin, we have here 29.167 pesos per meter ang pricing natin. But ang pricing natin here is not per meter, per kilogram. But we know that per every 1 meter, it is equivalent to 0.617 kilograms. Okay? So meter and meter will cancel out. Therefore, the pricing per kilogram is equivalent to, so we have it here. So 29.167 divided by 0.617 is equivalent to 47.272 pesos per kilogram. Okay? So going back here, the unit cost is 700 for the D10mm is equivalent to 47.272 47.272 pesos per kilogram. So this is in pesos per kilogram. Okay? So likewise with the D12mm, D16, and for the GI tire wire. Now from there, we can now solve everything. So we will stop from here because masyado nang mahaba. And I believe you already know how to solve this one. If you are not yet familiar with that, just go back to our video for concrete works and masonry works because we finished everything until this part. Now, if you have questions, just comment down below and we will try to answer them.